Welcome back to Green Disruptors, Scaling the Future. This episode's brought to you by Mountaintop Social Marketing, your growth partner and pipeline accelerator for sustainability companies. Today, I am joined by Jim Metropoulos, founder of BlueBox, joining us from New York City, originally from Manhattan Beach, California. We're skipping the small talk and jumping straight into the work because what Jim is building is one of those rare innovations that's both simple and massively consequential. A way to restore and maintain HVAC performance by solving a 100-year-old problem most buildings don't even realize they have. I'm excited for you to listen. Hi, Jim. Thanks for joining us on Green Disruptors today.
Thank you for having me on. This is great.
Yeah. We had a little bit of technical difficulties, and so we're not going to do the small talk portion of the
Yep,
intro. So we're just going to dive right in. So
absolutely.
tell us about you, Jim, first of all.
Yeah, I am currently in New York City. I just moved here, but I'm originally from Southern California, specifically this place called Manhattan Beach, California.
Mm-hmm.
And in my background, it's interesting because I'm UCLA political science, no engineering in my
Yeah.
background, or I didn't study engineering, and or any of these, or chemistry or anything like that. And it's so there's nothing in my background that would really. Everybody asks me how did I get into this, and while I didn't study engineering or chemistry when I was in college, it was I got my, I kind of cut my teeth on that with, I had a grandfather who was, was kind of an eccentric inventor type. He had 15 patents to his name,
Wow.
and he was the one that exposed me to all these different, innovating, coming up with different innovations, and he was in all kinds of crazy stuff. But originally when I designed BlueBox, the application we're doing now was not the intent. So I started in one area, ended up in another. And it was a system originally designed to do chemical cleaning in refineries and power plants. And what I was trying to do is how to improve the process of keeping big industrial equipment clean,
Mm-hmm.
as a means to improve their productivity, energy efficiency, and things like that, minimize use of water, chemicals. And it was a space that had not changed much in a very long time, really since the invention of like refineries and stuff. Like the processes they use to maintain the systems then is very similar to it is now. And during
Well, it's
that,
like wiping dust off of anything is the same as it was 100 years ago. It's kind of
yeah,
that's,
it hasn't really
yeah.
changed. And when you get
Mm-hmm.
into, and there's this whole universe around the world where, of like how to do preventive maintenance and how to keep big industrial equipment, running clean and running like new, right? And it's a big
Mm-hmm.
challenge. And when systems do not, when they begin to foul, they'll load up with all kinds of stuff. This kills their heat transfer, how they work. It consumes a lot more energy. And what I was working on was how to optimize these systems so that they always ran like new. They're way more efficient and when you look at like refineries and big equipment, they consume a tremendous volume of energy, their energy density. And so I had gone down this pathway. This is where I really started developing my techniques, and then I came across this innovation for HVAC that I was not thinking. Wasn't aware of the problem or anything like that, and it was one of these like accidental innovations. But it's a
Yeah.
innovation that really changes, as we'll explain, but it has a fundamental impact on how all homes, high-rise buildings, data centers, everything that work and operate, um, once you solve this fundamental problem. So,
Yeah, and you can see the potential for the effects on decarbonizing just because, one giant piece of equipment, if it's not running efficiently, it's just, yeah. So like the numbers add up really fast for it having a really huge
yeah, I
impact.
mean, if you're just looking at HVAC, right, as just one
Mm-hmm.
category of equipment, every modern building in the world is outfitted with a HVAC system. Most people don't, HVAC systems are back of the room. You never see them, right? No one
Yeah.
ever thinks about it. You just
You kind of
take it.
don't want to think about it.
You don't want to think about it. Trust me. And so no one sees it. No one's really familiar how they work. But every modern building, whether it's your home, your apartment, hotels, high-rise buildings, like the modern world, the foundation of the modern world rests upon HVAC. It's everything from, even if you're manufacturing, like car manufacturing is dependent upon HVAC. Semiconductor chips, like how you manufacture, is based on, because you got to control humidity. Processing food, baking bread. It's all at industrial scales. It's all dependent upon HVAC, and it's one of there's 2 billion HVAC systems in the world today installed.
Yeah,
Think about that.
that's a big number.
And you do not have AI without HVAC, because data centers.
Absolutely.
AI is dependent upon these massive data centers which are building, and you have to absorb and reject that
cool.
heat in order so the chip, those chips don't melt, right? Everything is dependent upon it. It's not just, being in an office environment and being, not sweating, right? It has so much more implications. But the technology itself is very fundamental. The technology really has not changed much in the last 100 years. And so, and what BlueBox does, I'll just dive into it if you don't mind.
Let's hear it.
So how HVAC systems work is all the air in a building has to pass through what are called heat transfer coils. And heat transfer coils are it's like a radiator, and all the air must pass through in order to be heated or cooled in order to have a climate-controlled environment. The way to think about it's like the lungs of the building, right?
Yeah.
And now, when you start getting into commercial systems, but this actually applies almost to every system. In your home, the coils are only a couple inches deep. In big commercial systems, they're 12 inches up to 18 inches deep. They're very densely packed. They're designed so only air molecules can pass through and nothing else. And since the invention of the HVAC system over 100 years ago, no one in this space had ever solved how to penetrate and clean the heat transfer coils in these systems. Now, why that matters, what happens is these systems are running 12 to 24 hours a day. And when warm air hits cold metal, you get condensation. And wherever there's condensation, biology likes to grow. If you ever walk in a building and it smells funky, what you are smelling are the coils, right? And that smell basically means that building's probably losing 30 to 50% of its efficiency because biology is growing inside the coils. So when the coils start to foul, they inhibit airflow heat transfer, which means the system has to work a whole lot harder.
I was going to say, do you ever get pushback on that 30 to 50%? Because I'm like, whoa, that's a lot.
That's on average. So
yeah.
When I first developed this was an accidental innovation, but we've now been doing this since 2016. BlueBox has been used to restore over 45,000 air handlers or systems around the country. We know what we're talking about. We take the readings, and the engineers that we deal with are shocked, right? They're like, wow.
It's like, it sounds too good to be true, but you've got the data behind it. So.
We have the data, and it's universal. If a system's brand new, if it was just installed like a year, 2 years, like it'll be fine. But after a couple years, and depending on where it's located or like the type of building, it will start to foul. Some places foul relatively slow, others really fast. The worst coils you will see consistently are in hospitals.
Which
And
is
the
scary.
yeah, it is. And the reason for this is because hospitals this is where all the sick people are at, right? All that, you cough, all that air in that hospital is constantly recirculated through these coils. Like I said, it's the lungs of the building. So they have a tendency to really build up with biology in these coils. And the problem is when they tried, historically when they've tried to clean these coils, they would pressure wash them, right? And you get these pressure washers. The way these coils are, and give you a mind, in a commercial system, coils could be 15 feet high.
I was gonna say, I picture them like taking apart the whole system and like getting
No,
it down on the ground or something.
It's like, imagine like a shipping container, right? And in there you have a coil and you have a blower that draws air through the system, and you have 50, maybe 100 of these containers distributed throughout the building, and all that air is continuously moved through, and so when they try to clean them, they can never, when they pressure wash, because of the way the fins are designed, they can never penetrate the coils. So you only get the outside 5% of the coils. And so 95% of what's going on deep inside has always been untouched and untouchable. Yeah. And this is where all the biology lives. So you can look at a coil and it looks spotless because the hospitals are actually trying to keep these things clean.
Yeah.
But it's the deep inside are just completely, they're plugged up. And so with BlueBox, what I solved with BlueBox is how to penetrate any depth of coil. And what we do is inject a odorless, chemical-free enzyme into the coils as a thick foam. It's like shaving cream. Mm-hmm. And the trick, and this is what I patented, is you keep the system on while you inject the foam, and the airflow of the system sucks the foam through the coils. And this is how you penetrate the coils. A really easy solution, actually.
Yeah.
And then the enzymes start to work and break down all the organic matter that's deep inside the coils. And then as the foam goes through the coils, it's like a glacier going through a valley. It just pulls all the stuff out, and it oozes out the back end of the coils. And all coils, all HVAC systems have these condensate drains, pans and everything around it. So everything just oozes out.
So it comes out through there.
Just comes out, all the junk from the inside comes out and just goes in the condensate drain. And because there's no chemicals involved, everything's pH neutral, it's safe to go down the drain, and voila, you have a brand new system. And it's interesting because like I said, in HVAC, no one had ever solved this problem. Like, it's 100-year-old problem.
Yeah.
And what the industry did, instead of solving the problem, what they did was engineered around the problem. So they build in all this excess capacity in facilities.
Oh, yes. Mm-hmm.
And so you design a system, oversize it, and over the years you'll lose capacity, and then you get to a point where you write a big check and cut out the coils, put in new coils. I mean, in a commercial system, to replace coils could be $100,000 to a $200,000 plus check, right? It just depends on the size and stuff. And, one building, you have 40, 50 of these systems, right? Like, so it's not cheap. And so by solving this problem, it's a interesting innovation, because once you solve this problem, like, buildings account for some like 40% of all global energy consumption and carbon emissions in the world. The HVAC system is the number one energy consumer in a building. It can consume up to 50, even 70% of the energy, depending on the type of building and stuff. It's the number one energy of the grid.
Number one.
Number one,
yeah.
Right? This is when I said, the HVAC system is, it's the foundation of the modern world, and no one thinks about it. It's the number one energy consumer of the grid. It's the number one driver of peak load demand of the grid during heat waves, because You
Yeah,
have a
that
heat
makes sense.
what is driving all that energy consumption? It's it's not the microwave, it's not blenders or anything like that. It's everybody's turning on their HVAC systems, and this is what keeps utilities up late at night is peak load demand, right?
Yep.
That's the thing that trips everything off. And at the choke point of everything are these coils, and nearly all of them are running 30 to 50% inefficient because of this choke point problem of the biofouling, and that's what we solved, right? So you think about it, like it's such a simple innovation, and I can't really even think of a parallel where such a simple innovation can have such a major impact on a national, global basis, right? Like if
Right.
every oil in the world were being biotreated with this, with BlueBox, where their coils are running clean, you can actually affect global energy consumption and global carbon emissions, plain and simple, right? So, but this is what we are. This is our mission, right? To how to control the biology in HVAC systems, and this is the key to how do you make HVAC more efficient. And then you also start thinking, like, once these, all these systems are loaded with bacteria and fungus and all these nasty microbes, and you can smell them, right? Like you go down to
Yeah.
Florida, every building smells like a wet dog. What you are smelling are the coils, right? And so you think about, what does that do to indoor air quality,
Yeah.
right? In a building.
So that has big
I'll
health
tell you right
impacts as
now,
well.
it's good, right? It's I say we deal with a lot of hospitals. I mean, we see systems where, I've seen systems where like mushrooms are growing out the back end of the coils, and these are feeding operating rooms, right?
Yeah.
Intensive care units, things like that. So once you solve it, it just checks off all the boxes.
Yeah. So you designed it purposely to require as little maintenance as possible for these people who, so is it a one-time install? Like you get the box wherever the coils
Well,
are?
so originally it was designed as a manual process. When I first developed this process, and it was funny, like it was, to give you an idea, it was interesting. It was a funny story in the beginning because I had developed this technique of how to use enzymes to break down biology or biofilms in industrial systems. And I was at this big automotive plant in Detroit looking at other systems. And we're walking through the plant, and this engineer stopped me, and we're walking next to what's this, you call them air handlers, which are these in commercial, in especially industrial settings, these things are huge, right? This thing was like 15, 20 feet high, 30 feet across. And he stopped me and he goes, "Hey, can you adapt your process to clean the coils in my air handler?" And I looked at him. I knew nothing about coils, nothing about air handlers. And I'm like, "Sure." How hard would it be, right?
Yeah, that's your grandfather coming through.
Yeah, a little bit, right? It's like sometimes it's better not to understand what you're walking into and just kind of. But it was interesting. I was able to solve the problem pretty quick because I was already doing up this process with other types of equipment. So it's not
Right.
like I didn't do anything, but I just didn't know. I didn't know anything about HVAC or that problem with that. So when I first developed this, it was a manual process. We would send in technicians, execute execute the process. You do it manually, but cleaning coils is like cutting the grass. It's going to refoul.
Exactly, yeah.
And so this year, what I did was I automated the system, and so now it's a very easy to install kit. You just it's a pump with a PLC board that controls the pump. You have a barrel of enzymes. You put nozzles upstream of the coils, and what they do is spray enzymes into the coils every couple weeks, and you're pulsing the system with enzymes. And
So the buildup never happens.
so then because if biofilms are, what happens is biofilms form when bacteria gets into a system and it starts to grow, and it forms these biofilms. It's like the protective nest. if it cannot form biofilms, that bacteria will not stay present. They'll die out. And so what we're doing is preventing it from biofilms forming, keeping it biofree, and then now you lock in the efficiency gains. So now we've been rolling out bioautomation, is what we call it. And we've got, like in New York City, one of the leading cancer hospitals in the world is on the Upper East Side. We have bioautomated 22 systems. We're about to do another 10 on the first units that we've done. I mean, the engineer could not be happier. It was like I think a 38% reduction in what's called pressure drops and improvement in airflow, and the system is just running like, fantastic, and it's consistent, right? And it's all automated. So once you automate these systems, now, kind of the way to think about it, it's almost like LED lights, right? It's in a building, your two main energy consumers are LED lights and HVAC. And it used to be 50-50. Lights were like 50% of the energy, and HVAC was the other 50%. And then, everybody retrofitted with LEDs, and you saw, like a 20% improvement in building efficiency and things like that. And it's interesting because to automate a high-rise building, like compared to LEDs, it's like cakewalk, because if you have a 1 million square foot building, like 40 stories, to convert that building to LEDs, you have to swap out 25, on average, 25,000 light bulbs.
That's a lot. Yeah.
It'll take you about a year, if not more, right?
Wow.
And the disruption to the building and all this stuff, et cetera. And you're going to see about a 20% improvement, right? And it's going to cost you, $1.5–2 million to do that, right? It's going to be a 3–4 year ROI. With BlueBox, we can bioautomate that same building. That same building will have 40 air handlers. We can automate it in 7 days.
Wow.
And there will be zero disruption, because no one can tell when we're working on these. We don't shut them down. There's no disruption. It's completely odorless. You can automate it. It's very quick and easy, and it will cost, roughly, let's say it's, for a high-rise building, say it's like, it'll be like $150,000, right? Your energy savings just from that should be about $250,000 in year one.
You're 2.5 times return in the first year.
It'd be less than 6 months, and then after that, all you have to do is replace the enzymes, and it literally costs like 2 cents a square foot for a building, because right now, the cost of coil fouling probably costs buildings anywhere from 25 cents to 50 cents a square foot. So if you have a 1 million square foot building, that's $250,000 to $500,000 a year just on the excess energy consumption from the coils, right? So for 2 cents, 2.5 cents a square foot, right, you'll never see 25, 50 cents. And that's on the average, right? Like, when they really start to foul, you're at $1 plus a square foot.
Yeah.
And that's just on energy. If you have to replace the units, holy moly, the cost really starts to
there's pretty
skyrocket.
much nothing you can do for efficiency that's going to get you a return that quickly. That's amazing.
No, this is one of the things that we're really pioneering is one of the hard things about, like, let's say the climate tech or the green space per se, is that's great and all, but what's the ROI, right?
Yeah.
And everybody's looking at it like LED lights, right? It's more energy efficient, but it's not cheap, and you're replacing the existing infrastructure. And it's going to take 3–4 years, 5 years.
I was going to say, just the disruption alone would be a lot that would
just
make people
disruption
not want to do it.
and all this stuff. Whereas, you know, our clients, when we come in to do their systems, they're not trying to hug a tree, right?
Yeah, they're just trying to save money.
They are trying to restore performance and restore their systems to brand new, right? And that's a sign of a true innovation, because yes, it's improves indoor air quality, right? It reduces building energy consumption. It reduces building carbon emissions. But that's all coming for free, right? Or not for free. Like, that's not the main, what's the
Right,
main
that's
driver?
a bonus. Yeah.
Right? And this is what really places BlueBox as very unique, in that our value proposition is just a no-brainer, right? And
Yeah.
it's and so especially now with automation, because you can automate a system now. It's the labor that goes into, if you want to maintain these systems in your own way, it's the labor costs. And if you're a building, if you're a hospital, you got to treat those coils 2, 3, maybe 4 times a year. A lot of places have small operations teams, and if you have to bring in outside labor, this is what drives up the cost. And so now you automate it one time, you restore everything to brand new. That's part of the what we charge, and then moving forward, you're back to brand new, and we're locking it in so your systems are always running brand new, and then that just has a massive impact on equipment life and everything going forward. So it's interesting. Once you solve this choke point problem, it has this great economic impact, and then you have all the environmental benefits that result because of this, right? But we're not trying to lead off.
That's not the value proposition. Yeah.
Yeah, I'm not trying to lead off with, listen, you got to use this because of carbon reduction. I'm like, I don't
say no moral argument necessary.
Yeah, exactly, right. This is not our kind of thing, but this is the true key to. This is where I think in the debate, or when you start looking at how to transition to how to decarbonize different industries and things like that, right? It's really, the focus is how to make them way more efficient, how to solve key problems that make them better.
Yep.
Right? Like, it's, and so, yeah.
Yeah. So, with a solution that is going to get people that high of a return, it's a no-brainer and everybody needs it. What is your go-to-market strategy, and sometimes it's hard to just find the right customers, but I imagine it's going to, tell me what that's looking like.
Yeah, Elizabeth, and it's interesting because no innovation sells itself. I don't care how great it is.
That's the truth.
Like, you got to go out and really, drive. So our strategy, what we're doing. So number one, we've been pushing out our manual process, but we have now started developing a partner network. We've been working with mechanical engineers and the ecosystem of HVAC, or we'll go to facilities and we supply them the BlueBox system and the enzymes. We'll teach their people how to do it, let them self-service, self-execute, right?
Yeah.
And then we have automation, and so it becomes start manually treating your coils, get them back to good, and then start automating your most critical systems. Like, if you're a hospital, you should automate at minimum your operating rooms. That's your money generator, right? And we start off with there, and then you just kind of expand out, as it makes sense for you. And then, so it's this strategy of going after the ecosystem, but we're training, actually teaching all the, these are guys that have been in HVAC for their whole careers. And it's interesting because this thing with the coils, it's everybody's pain point, but no one ever really thought deeply about it or really understood the problem. So we're
Interesting.
teaching everybody about it, right? Like
So there's
all
an
the
education gap.
it's an education thing, right? Like, and it doesn't help where it's the coils. It's kind of that part of the HVAC system because there's never been a solution. Everybody's always tried to, how to solve this problem, but everybody's failed, right? So when an engineer hears about this, they're skeptical at
Yeah.
first. It's really easy to get them over, but they're always skeptical. Like, how's this different, right?
Yeah.
Because the industry has used foam before, they've used different chemicals and all this stuff, and they don't truly get like what makes it so unique. And what makes it unique is the enzymes combined with the process of keeping the system on, right? That's, like I said, that's what we patented, and there's an education. It's an industry that has barely changed, right, in decades.
People aren't actively looking for a solution because they're just going to
Yeah,
keep doing what
because
they've
they
always
they've
done.
learned to adapt, and everybody's put it in there. So, but it's also an opportunity because
Yeah.
it's so easy to show the savings and the performance and all these things. So it's starting to happen. But I mean, give you an idea though. I mean, my first major client when I originally developed this was the Bellagio in Las Vegas.
Not too bad.
And yeah, and I mean, the results were outstanding. Then I did Mandalay Bay, Luxor, Excalibur, the Mirage, MGM Grand. BlueBox is in the Wynn, Encore now,
So cool.
Stratosphere. So we've done like half the strip. In New York City, we've treated the Empire State Building. I just had a meeting with them again just a couple weeks ago. They're very interested in automation, for it. We just did our first projects with the Metropolitan Museum, Columbia University and stuff, and around the country. I mean, we really it's now starting to. We've made our inroads, right? And so,
Yeah.
But it's but yeah, it's a lot of education and just showing the process and the results. But we collect all the data. So now we have so much data, results, et cetera, and very good clients too, that things are moving faster and faster and faster now.
Yeah. I thought of a really cute cartoony commercial for you where these buildings that everyone knows are personified and they can breathe better because of their blue box.
Yeah, well, this is interesting because I've been focusing on the big commercial buildings, right? And with automation, this now will start opening up residential applications. And it'll be interesting when we go after the residential. I'm not going to, like, that discussion is probably going to be all about indoor air quality.
Yeah.
Right? It's like, if people knew how bad their, like I say, you never see your HVAC system, you definitely never see your coils. If you got a picture of what's going
Well,
on.
even just changing that filter scares you a little bit.
Yeah. Yeah, and that gives you a little indication. But if you were to take a microscope and take a look inside what's going on in those coils, man, especially if you're down in the South or Florida, like,
somewhere that's humid.
oh, yeah, where the humidity's at, it's catastrophic, right?
Yeah.
So automating the system is super simple, but it'll be like put it this way, I think the U.S. spends something like $10 billion a year on air purifiers, right?
Yeah.
What air purifiers doing, they're downstream of your HVAC system trying to keep that air clean.
They're trying to pick up the debris from an explosion.
You got to, go to the source.
Yep.
Keep your HVAC system bio-free, keep it healthy, no chemicals, and have it inject into the system, continuous, and it's interesting because most people will replace their HVAC system every 10, 15 years. The reason why you replace your HVAC, and HVAC systems in a home are not cheap, right? That's a big check. The number one, the reason you're going to replace it is because you start noticing your system is not working that well anymore. It's not getting cool like it used to. And your guy is going to tell you, well, your heat exchanger is no longer working. All that means is that your coils are plugged up and he has no way to unplug them. right?
Okay, this is making me equally happy and angry. So,
Yeah.
I mean, you've sold me, Jim.
It's not their fault. I mean, they never had a solution. So
Sure.
what we want to do is start working with all the installers and that like the residential guys, and because now if you had a system that was automated, you'll double if not triple the life of that system.
Yeah, I believe it.
Yeah, based on that.
Okay. Well, congratulations. This is an amazing innovation. Glad you've got the patent, and I will love to follow up on the progress and I'm sure,
Yeah, thank you.
widespread adaptation. So, appreciate you
Well, thank
coming
you very
on.
much. All right, you take care. Bye bye.
Okay, bye. Jim, thank you so much for coming on the show. This was one of those conversations that makes you look at the built world differently. The big takeaways: HVAC is the hidden engine of modern life. And if the coils are fouled, buildings quietly bleed energy, money, and air quality. BlueBox's approach is compelling because it doesn't require a moral argument. The ROI and performance improvements speak for themselves. If you enjoyed this episode, make sure you're subscribed to Green Disruptors and share it with someone who touches buildings, facilities, data centers, healthcare, or energy efficiency. This show is sponsored by Mountaintop Social Marketing, your growth partner and pipeline accelerator in sustainability. Thank you for listening, and I'll see you on the next one.